really fun speaking at new groups, especially ones that I could one day visit, perhaps. Right now, no one's really visiting a lot of people yet, but that's going to change pretty soon. It kind of already is. So I'm looking forward to that future, and it'll be fun to be out there. I've been to Colorado in many years, so that'll be pretty awesome. This session, and by the way, this is very informal. Feel free to unmute and ask questions if you want during the presentation. Interrupt me. I don't mind at all. It's really meant to be interactive. I don't want to just talk for an hour. I can, but we're all going to fall asleep if I do that or go crazy. So we don't want that. This session is all about something that is interesting because everyone thinks they have solutions to it. A lot of people do, and they're usually not right. Or they find something that works and it's just kind of crazy. And I've seen things in production that just blow my mind. So this is really an interesting presentation. It's fun. It's a fun topic, and we can get a few laughs out of this because we're all have seen things like this before somewhere. So this is all about parameter sniffing, and we're going to talk all about what it is and define it and go right to the heart of it, all the solutions. It's going to be a lot of fun. At the end of the day, the solutions aren't that complicated, but a lot of what we see out there, especially in the internet, is just totally crazy. So the goal here is to avoid crazy today. So we're going to avoid crazy because we don't need that. And by the way, what time should I kind of focus on finishing by, just so I know?
I would say try it in an hour. I would say about 60 minutes kind of time frame. Yeah.
Sounds good. Just making sure I don't want to go until some ridiculous time or finish in 5 minutes. I could do that. Okay, great.
Yeah, just talk really, really fast and then I'm done.
Kind of known for that, actually, so that's fine. But
yes,
anyway,
we run over a little too. That's fine. It's not like a conference where I'm really worried about the time so much. There's not somebody behind you, so it's okay.
Okay, great. Thank you. So this is me. I've done a lot of stuff in the community for a while. I enjoy data. I enjoy playing with it. I enjoy learning about it. I enjoy talking about it and writing about it. I've written several books. I've written a pile of articles. My current position is I'm a senior data architect over at a company called Datto. They're a cybersecurity / backup / kind of online continuity business management company. They have a lot of stuff they do. I enjoy working there. I organized the SQL Saturday out in Albany, which we've run for 7 years, and we're hoping to have one in person this year in July. We're just kind of buttoning up the details and hoping that works out. One note on the books I have here is the Analytics Optimization with Column Store Indexes book is new. It just came out a few days ago. It's published by A-Press. So this is new. If you're looking for a new book to delve into storing analytic data in the SQL Server, feel free to take a look at this. I really enjoy what I did here. It's a lot of fun, and I put a lot of good material in there. So if you have questions about it or anything, feel free to contact me. I have my Twitter here. I will also have my email later on as well. If you have any questions about this topic I'm presenting on, or me, or books, or anything else, you want me to come present at some event you have, anything else, just feel free to ask questions. I love questions. Connect with me online. That makes us a lot more valuable. We're a big community, and so that's fun to be a part of. So that's me. You're not here to learn about me, though. You're here to learn about what we're talking about. And so that's parameter sniffing. What I plan on doing here today is reviewing the plan cache quickly, reviewing plan reuse quickly, and defining parameter sniffing quickly. And then spend the rest of the time really talking about how to resolve it, the good ways, the bad ways, the ugly ways, and just good patterns for writing better code so you don't continuously run into this problem. And even if you do, how to solve it. And along the way, we'll get a few laughs. We'll have some questions. Feel free to jump in. We'll discuss, and then be done. That's the plan. I'm making the first chunk of this pretty quick because in case you already know a lot about this, I don't want to spend an hour reviewing things you already know. So I'll do the review quickly, but concisely enough that hopefully it's good. Here's a basic idea of how a query processes from beginning to end. When you go into Management Studio or into an app and you have T-SQL and you execute it from anywhere, the first thing that happens is it gets parsed. That means that SQL Server looks at the syntax and the keywords and the things that you type to make sure, does this even make sense? Is the syntax correct? Is there anything misspelled in there that makes no sense at all? Did you misspell select? Something like that. Did you fit semicolon before a CTE or something? That's parsing. Parsing is 100% syntactical. It's verifying that you didn't mistype things or not follow the correct T-SQL syntax. It's really just checking, is your T-SQL sound? If you pass parsing, great. If you don't, you'll get a syntax error. Big red error message immediately. It won't even let you go any further. Once you pass parsing, you move to binding. Binding is where SQL Server checks all the objects you're referencing, tables, columns, proc names, views, whatever. It checks to make sure those objects exist and that you're referencing them correctly. The inputs, the outputs, and so on, everything is correct. If you fail this, you'll get an error message immediately, something along the lines of that object doesn't exist or wrong parameters for the thing. You'll get some sort of error immediately telling you you can't do that. If you pass binding, great. you're now on to optimization, which is really what this presentation is all about. Optimization is where SQL Server says, all right, we know basically what this query is all about. We need to figure out, though, how to get the data and go from your tables, wherever they're stored, to results or updates or inserts or deletes or selects or whatever it is you're doing. And that is your execution plan. So optimization will basically create a step-by-step process for how to get your data. And the result will be an execution plan, which is the step-by-step with a lot of details built in. Once you have an execution plan, SQL Server simply executes it. The execution engine says go and follows whatever the execution plan is, good, bad, ugly, whatever. It just does whatever is there. And so really the optimization is the expensive step in processing a query. It's the expensive step. It requires CPU. It requires time. And it's not cheap. And it's critical. You can't execute a query without optimization. And that's what our presentation will be about today, which is query optimization. And again, if there's any questions, feel free to jump in when I take a breath.
Okay,
yeah. Happen to be.
No, yeah, it's good. It's good so far. So good.
Okay, great. I may not breathe very often, by the way. So if I don't breathe for a long time, you can still interrupt me. It's perfectly fine.
Okay, I can just interrupt and say, you need to breathe right now.
If you see me turning blue or passing out, feel free.
Okay.
Hasn't happened in my life, but it could be a first time. So
only if you turn blue, though.
Yes,
only if you
turn blue,
okay.
Please interrupt, and it'll be caught on video, which is even better, right?
Yeah, right, exactly.
So what's an execution plan? This is a very simple image of what an execution plan looks like. It could be simple, like a few operators. It could be complicated, like many operators. And at the end of the day, it's read from right to left. Right to left? Or is it reversed like this? I can't tell on the camera how that goes. But anyway, it goes from right to left. On the right are all of your reads, and on the left is your output. So inputs on the right, outputs in the left, and you'll have things in the middle, like seeks and scans and lookups. You'll have joins that bring data sets together. You also have writes, such as writing to a clustered index or a non-clustered index, and so on. So this is an execution plan. It's a very simple idea of what it looks like. I'm not going to go over all the operators today. You can learn about those pretty easily online, no problem. The optimizer, though, has a hard job to do. It has to turn all that stuff that you put together in your query into an execution plan, and that is not a simple process. What it needs to basically do is use statistics and any metadata and objects that you have to basically put together a big list of plans that might be good. It makes a big list, and then once it has a list of plans that might be good, it begins assigning costs and checking them and seeing. Somebody might want to mute here, by the way. There's some noise going on here. Thank you. That was fast.
Oh, well, I muted Manish. I think he was the only one unmuted. Sorry, Manish, I just muted you, but yeah, there was a noise.
All good. So
I'm sorry.
No problem. Optimizer will assign a cost to every plan based on a whole bunch of transformation rules to figure out what is each plan worth and what's the lowest cost. And cost is an arbitrary number. It's the cost of an execution plan when you see it. It's not CPU, it's not milliseconds, it's not kilowatts. It's just a number. It's arbitrary, but it's relative. And so SQL Server will believe that a query with cost 1 is cheaper and faster and better than one with query cost 10. That's all. And then it basically evaluates as many as it can in as short of a time than it can until it comes up with what it thinks is the best candidate plan. It may not be the best plan, but in the short period of time it had to analyze it, it thinks it's the best plan. This is basically kind of like a chess AI trying to figure out what the next move it should make is. So you made a move in chess. SQL Server's got to say, what should I make as the next move? And it's got to do it very, very fast because we can't all wait. If you hit F5 on a query and wait an hour, that's very, very bad. So generally, it's going to try to get an execution plan in sub-second, as fast as it can. The faster, the better. But it's going to take a little bit of time in CPU to figure out what the best plan is. The more complex the query, the more tables, the more views, the more operators, the more things you're doing, the more complex the optimization process, the more complex the plan, and therefore the more chance there is of something maybe going wrong. And in general, things don't go wrong often. More often than not, it'll get a great plan. But the more complex the query, the more chance there is of something going wrong. Real quick demo on what does an execution plan look like. Here's my management studio. I'm headed to my local server, and I run a query against my server, a simple query. I get my results for a very specific, I want to know all the orders for a certain customer. Give me back 3 columns. Very simple query. I get back 81 rows. And I can look here and see my execution plan. Straightforward. I have an index seek, meaning I went to an index, clustered and non-clustered, and I grabbed some data from it and said, I need more columns. Went to the key lookup, got the additional columns I needed. It brought that all together into one data set and returned it to me over here to look at. If you hover over your execution plan, you get mountains of detail. Mountains and mountains of detail. Costs, I/O, CPU, actual, estimated, mode. More things than I ever want to talk about here today, because it's really about parameter sniffing, not about decoding execution plans. You can hover over the lines to get row counts, estimated, actual, and so on. So this is a very, very rich piece of information full of detail. That is what SQL Server made in milliseconds when I hit F5 just now. It did all this work and came up with this. So it's a pretty amazing tool. That's what a plan is. I'm going to keep going. Now, because a plan is very expensive, we don't want to keep doing this over and over. If I have a busy server that runs millions of queries an hour, I can't afford to optimize every single one. It's just too expensive. So what SQL Server does, and really most database engines in the world do, is they will generate an execution plan and then cache it. They will place it into memory in the plan cache. And the plan cache can store many, many, many plans. The limit is really just based on RAM and on some internal limitations of SQL Server that are pretty beefy, but there are some limitations. It stores them and saves them for later use. That way, if the same query comes along again, it says, I already have that plan. I'll just use it. No problem. Great. And that's basically how it works. It's all in memory. This is not something stored in TempDB. It's not stored on disk. It's in memory. That way, if SQL Server restarts, your cache is emptied out and you start all over again. Not a big deal. It's by design. That's just how it works. Plans can age out. They do not stay in cache forever. If there's memory pressure, old plans get dumped. If things change, like your object definitions change, plans get dumped out of the cache because they're not relevant anymore. All of this is done automatically by SQL Server. You can influence it with query hints and settings and trace flags and all kinds of stuff that you can do that you probably don't want to do, but you could. But in general, it's all automatic, and you shouldn't mess with any of this unless you truly, certainly, without a doubt, know what you're doing. A key to the execution plans is that every plan is based on the exact text of a query. So if I type in a query and I have one number, and then I type in the same query and have a different number, two different plans. If I have a comment in this one and no comment in this one, different plans. If I have a white space, different plan. That's very important. So what does the plan cache look like? First off, I'm going to clear my local cache. Don't ever do this in production, please. I'm just doing this here as a demo to clear out my cache. This will clear the cache on the whole server. If you do it in production, and your cache is cleared, the server is now going to have to do a lot of work to begin populating all plans all over again. It'll cause latency in a busy application. Don't do that. But I'll do it here. I cleared my cache. Awesome. My local server is free. If you want to be more specific, you can clear the cache in one database like this. Grab the DB ID, pass it into this this function, and then run your dbcc, and I clear the cache in my one database. A little better, but again, don't do this in production unless you really mean it and know what you're doing, because you're going to probably cause trouble. Dev, QA, home, whatever, fine. I run a query now. Same query as earlier. Give me all the orders for a certain customer ID. Run it. Done. There's my plan. Beautiful. I have a query here I'm going to use for the remainder of this presentation that goes out and grabs details from the execution plan. I'll share all these files afterwards with you so you can steal this code and use it yourself. Feel free to enjoy it. This query returns a pile of data. You may not need it all, and if you don't, no problem. Basically goes out to some dynamic management views in SQL Server and returns information about query stats, SQL text, the query plan, and the text plan. And I filtered it down a little bit to only give me back what I need. If I run this query, I get back the one query that I ran before it. This is one execution plan that I have in cache. I know the reads, total, last, the number of executions. I have the actual execution plan XML here. I can look at it. That's pretty cool. I can store it somewhere if I want. That's great. Last execution time. Lots of information here. Vast amounts of information, including the query text. I can expand that and look at it and see my query text. So a query like this is very valuable. It tells you tons of information. Might be TMI, might be too much information, but it is extremely useful. I'm going to use the same query throughout the rest of the presentation to kind of give me information on what's in the cache. Now, let's say I run the same exact query as before, but I change the customer ID from 1015 to 1018. Done. Now I do 1020. Now I do -1, whatever. I run it anyway. No rows are returned, but who cares? I ran it. Now I go back to my cache and I look at it and I see that I have 4 plans in cache. So each time that I ran that query with a different number, I got a different plan. So the key here is that if you run ad hoc queries that have detailed text and fixed values, they're going to all get their own plan. If you're in a busy production environment that has the same query running a million times on all different values, you don't want this because you're going to run and optimize it every single time. Your plan cache is going to fill up with a whole bunch of plans that are all kind of the same. It's going to have to dump plans and keep doing this all the time. So your server is going to have to work really hard. It's going to waste CPU. It's going to waste time. And you're going to, wherever you're hosting your stuff out of, whether it's Azure, on-premise, AWS, you're going to be paying more money for it. So this is bad. You don't really want to do this in a production environment for a query that runs often. The solution to this is parameterization. You can, by using stored procedures or ad hoc parameterization, have SQL Server parameterize your query and then create a plan for it, and that plan will remain the same no matter what your parameters are. And that's great. So you have the same execution plan for 100 parameters or 1,000 parameter values or 1,000,000 parameter values. And this is basically what plan reuse is. If you want to reuse an execution plan that isn't simply going to be the exact same text over and over, you parameterize, and then you can use it over and over and over with the same plan. My plan can be used 1,000,000 times, and SQL Server won't care. In fact, you'll love that because now I'm avoiding having to do something 1,000,000 times. It's expensive. Ideally, you want to optimize plans as infrequently as possible and reuse plans as often as possible. I'm going to stop really quickly here and just ask, are there any questions so far? Anything I've talked about? Execution plans, plan reuse, parameterization?
I have a question.
Sure.
Yeah, so the query that you ran to get the plan cache, is there any issues, or does it cause any performance or locking if you would run that in production?
Great question. It won't cause locking. It won't break anything. I will recommend, though, if you think the number of rows being returned is large, do put a top on there, put an order by, because I am returning query text. I am returning query plan. So it is a lot of data. If you return 1,000,000 rows this way, it will be a little slow. You won't break anything, but you might break your patience. So I definitely recommend putting a top on there, an order by, just to limit the amount of results. I put some filters here to intentionally grab what I wanted and nothing else. If I remove the filters and ran this thing with everything, I got a whole bunch of garbage I don't care about. So definitely filter. No question. That was a great question to ask. Definitely a good idea to filter and not return the whole world of results. But great question.
Thank you. One other question on that too. I noticed the database name was null. Is there a way to get that? Is that just another cross apply that we need to pull in, or?
Yep. If I had a use statement in there, it would include the database name. Ultimately, you can do that, or if your query, it really depends where your queries are coming from. Ultimately, some people put a use statement in all their queries, some include it in the connection string. Some people will have the database name in the query itself. A lot of that's really up to you and how you want your queries presented. If you have one database or 10, it's probably easy. If you have 1,000,000 databases, you might want to have something in there to give you a hint as to where it's coming from. You can add a lot more information to this too. This is just the execution plan data. You can easily join into other views like DM exec requests and sessions and get all kinds of session info and go overboard too to get more information. So this is really, I'm trying to return not too much information, but this is a lot of information. You could add more if you'd like.
Okay, thank you.
Sure. Great questions. I see somebody's waiting in the lobby. If somebody else wants to let them in, that would be cool. And I will continue. That means jump into a demo because I love demos. Demos are fun. They break. They're exciting. We all love demos. So to illustrate parameterization, I'm going to clear my cache. Again, don't do this in production. Please let you know what you're doing. Thank you. I'm going to create a very simple store procedure that takes the query that I ran earlier and just wraps it into a store procedure. So get customer order details, one parameter, customer ID. This is my exact same query from earlier, except that now I have the parameter being passed in instead of the literal value. I'll create my brand new store procedure. And now I execute it for my same value as earlier that I tested before. Same results, runs very, very fast. But now, if I go in and run my execution plan cache query and look at it, you'll note that the database name is there. The reason is because the proc is in this database. It's an object nested in the database. In addition, the query text is no longer the query text. It's actually the proc text. So I'm executing the proc with this parameter, and that's got its own plan. And you can check and see there's my plan. Oh, that's not very interesting. Sorry. I'll have to go adjust that later. Sorry about that. OK. I'm going to run a whole bunch of additional executions for different values. Some are real values. Some are the sorts of things that QA would do if they were having fun testing me. Go QA. And then I'll run this one a few more times for fun, right? All right, cool. Now I go back and look at my cache. And what you note is I have only one row in here now. So my one plan from earlier got reused a total of 12 times. It was created and then used over and over and over for a total of 12 executions. And I can see my total reads, my last logical reads. I have my total worker time. So I have all this information here that tells me how efficient my plan was, including last execution time. So I have a very good idea here of what's going on. And again, the execution plan shows that it's optimized for a parameter. Perfect. This is plan reuse, and this is what you want in a production environment by default. There's no reason you would never want this unless you had a specific use case or a reason to not want this, a very good reason. Cool. Let's jump back for a sec and talk about the whole point of this presentation. The point of this presentation is parameter sniffing. What is parameter sniffing? Plan reuse means you take a plan and you create it and reuse it. But what if you create a plan for an unusual parameter value that isn't typical? Then you reuse it for typical values. What happens? What if your first value of your parameter returns 1,000,000 rows and all the rest return 1? You may get a plan that is not optimal for all the rest of the values, and that is what parameter sniffing is your execution plan was created, and it is created for a value that is not representative of how you're going to use this plan, and then it gets reused over and over and provides a lousy plan for all the rest of your executions. This is a side effect of plan reuse. This is not how things typically work. It is an unusual scenario. We should treat it as such. This in general is a feature, not a bug. You don't want to turn it off. You don't want to break it unless you have an extreme use case where you know you shouldn't be doing this at all, and that's unusual. There are cases for it, but it's unusual. What does parameter sniffing look like in SQL Server? I'm going to clear my cache again. I'm going to add an index to help me out here on order date because dates are great dimensions to sort by and do things by, filter by. Create a brand new proc that filters by date. I give it a start date and an end date. It returns some columns from in between telling me some data about my orders. Great. So now I'm going to run a query here and execute my proc for a narrow range of dates, for 2 dates. Here's my execution plan. I see an index seek and a key lookup. They join together, I'm done. Great. Let me free the proc cache again and run it again for a different set of values for a very large date range. So it's going to return lots of orders, very high cardinality. I run that, getting a mountain of rows back. I check my plan and I see I have a cluster index scan, which at first you may say, oh, scans are terrible, but returning most of the table, a cluster index scan kind of makes sense. It's not invalid. You may want to add an index to support this query if it's really executed often, but for what I did here, this makes sense. I returned a ton of rows and the scan makes sense. All right, cool. Now, what happens if I were to execute this query with the big range and get my index scan and then run it again with the narrow range? I use the same plan. And this is parameter sniffing. So I had one very unique set of values, ran my query, got back my results, ran it for a completely different set of values of totally different cardinality, 100 rows instead of 50,000 rows, and got the wrong plan, at least what I would consider the wrong plan here. And that is parameter sniffing. You create an execution plan, it's for an unusual value, you reuse it for different values, and get the bad plan reused over and over. And that is the challenge we're going to talk about today. And the remainder of this presentation is going to be all about what do we do about this? If you have parameter sniffing, what do you do? How do you solve it? What are the types of things you want to look for and try to fix? Before I dive into all the solutions that will make us cringe and laugh and smile and other various emotions that are unusual, any questions so far about anything I've talked about with plan reuse and parameter sniffing?
Hi, Pollack, Virish here.
Sure.
Yeah, I have one question. Suppose whenever we create a procedure, so with the parameter sniffing, so again, if you want to add anything in the modifying the SP, again that execution parameter sniffing will be changed or it will remain same.
If you alter the procedure,
Yeah.
if you alter the stored proc, any execution plan in cache for that proc will get removed, and it'll create a new plan when you run it again. That's just
No,
by
sniffing.
definition.
Sniffing. Parameter sniffing I'm talking about.
Okay. Oh, so what if you like recompile the proc as a
Yes.
result? Okay. We'll talk about it shortly, but if you do recompile it, you get a new plan. If you recreate your proc, you get a new plan. If you use recompile, you get a new plan. That is one thing we'll talk about shortly and a way to deal with sniffing potentially.
Okay. Okay, thank you.
Sure. I'm going to dive in. What can we do? Diagnosing parameter sniffing is not that hard, honestly. It really isn't. You'll see telltale signs in a production environment or even a dev and QA environment where maybe you have less control over the data, where it's happening. The most obvious sign of parameter sniffing is going to be that your proc runs inconsistently. You run it once, it's fast. You run a different time, it's slow. People in production report that, hey, this page is slow sometimes and fast other times. In other words, you find that things are inconsistent. Sometimes it's fast, sometimes it's slow, and it does so without any schema changes. It wasn't like you released a bunch of new code and suddenly it's fast or slow. It's just sometimes fast and sometimes slow, and nobody knows why. That's a very good sign that you have sniffing going on, that plan reuse is resulting in plans that are sometimes good and sometimes bad. When you begin digging in and asking, why is this proc giving me trouble? Take a look at it. How big is it? How complicated is it? Does it have a lot of parameters? Are there a lot of switches in it? A lot of procedural logic, if, then, else, while, then, go to. Ugh. Things like that can result in sniffing because you have a big complicated proc with big complicated logic, and those paths can change. And you may optimize a plan for one code path and then get a different code path later. So the bigger the proc is, the more complicated it is, the more opportunity there is for sniffing. Branching logic is notorious for that. Lots and lots of parameters, complicated parameters, weird parameters are very, very common signs of parameter sniffing. And another sign of parameter sniffing is you try to fix it, and you find that hacking it and poking it and playing with it seems to fix it a little bit, but you're not sure why. These are all signs you may have parameter, and there's more signs too. You may have parameter sniffing going on. These are some of the signs. And as we talk through the rest of this presentation, more signs of parameter sniffing will come up, I promise. And you'll see more reasons why these things can happen. So how do we resolve it? The remainder of this is going to be all about how do you resolve it. The good, bad, I'm going to pull no punches here. I'm going to talk about good ideas and bad ideas. And if you've done a bad idea before, don't feel bad. I have too. We all have at some point made a mistake. Perfectly normal. It's totally cool. We all do it. The key is to not make more of them, though, and learn from those mistakes and not do it again. So how do we resolve parameter sniffing? Here's a hack. This is definitely a hack. Don't do this, but I've seen everything I'm going to talk about here. I've seen in production environments, in big applications, in ways that just are cringeworthy. Sometimes people will say, hey, parameterization is bad. Let me redeclare my parameters locally inside of my stored proc, and that will solve the problem. And it doesn't really solve the problem, though. Local variables, just like when you have variables you make up anywhere in SQL, they don't benefit from statistics. Statistics are really critical to the optimizer doing its job correctly. If you don't allow it to use stats, it can't make good decisions. Stats tell SQL Server when it optimizes a query about how many rows are in the table. What's the cardinality? What's the density? What do I kind of see in the table in terms of values when I run my query and on these indexes that I'm using? And when you redeclare your parameters locally, you get rid of stats. SQL Server cannot use detailed stats histogram anymore. It's forced to basically guess and do a guess of, if I were just pick a third of the table, what would it look like? And it guesses. It's a rough approximation, but very often when you have a very serious parameter sniffing issue, the wild guess may be good enough. And so you'll do this, it'll work, it'll be faster, your users stop complaining, and life is good. But unfortunately, you didn't really fix the problem. You kind of hacked it, and it's going to haunt you in the future because this hack will eventually cause more problems in the future. It won't work forever. It will eventually lead you to having bad plans at some indeterminate time in the future. You're going to have to deal with it then. To put it really simply, this is a hack. Please don't do it. I will demo how this works. So let's say I have my proc here, same proc as before. I have my proc, I bring in a start and end date, and inside of the proc, I declare two local variables, and I assign them the parameters that were passed in. So now I'm going to operate and run my query using local versions. So I've completely hobbled the optimizer. I can no longer use stats the way I should be able to. So I go ahead and I create this brand new proc, and I execute it. Here it is. I run it for a very narrow range. I got an index scan. That's not right. I don't want index scan when I want 1 day of data. I want a very narrow seek. That's what I expect. I didn't get it. All right. Let me run for a big chunk of data. I get back a whole pile of rows. It did a scan. That was correct, but it wasn't, I got it through luck. Cool. Luck is good. That's great. If I run it for the, period of time where I get no rows back. 0 rows back. My cardinality is 0. I should get nothing. I still scan the table. The moral of the story here is that this brand new execution plan may be good sometimes, but it won't be good all the time. I've completely hobbled SQL Server. I've forced to do a scan. It had to guess. And you can tell here because I look at execution data here about estimated rows and actual rows. And I can see here that it read 73,000 rows and returned 0. Well, that's weird. I don't really want the estimated rows, 12,000, actual 0. So you know immediately there's a problem here. SQL Server is not making a good decision. So the moral here is don't ever redeclare your variables locally, ever. It's 100% a hack. Just don't do it, ever. If you find this, remove it and find a better way to do your proc logic to avoid this. Just trust me, it's bad, it's naughty. If you have trouble getting rid of it, we can chat sometime, but don't do it. It's a hack. Don't do it ever. There you go. Just don't do it. All right. Here's something somebody mentioned earlier about recompile. You can add query hints to queries that tell it kind of how to execute. Query hints are something we should always use carefully. Whenever you use hints and options and trace flags, things like that, you're kind of telling SQL Server how to do its job. You're saying, hey, optimizer, you're smart. You were developed by really smart people, but you know what? I'm going to tell you what to do. In general, just keep that in mind whenever you use hints. You may have a good use case for hints, and that's fine. Just remember that you're basically overriding the optimizer and telling SQL Server what to do. And if you don't know what you're doing, you're probably doing the wrong thing. Recompile is a very specific hint that says, hey, SQL Server, don't reuse a plan. Every time you run this query, generate a brand new plan, no matter what. Take the current parameter values, the current literal values, whatever you got, and make a brand new plan. That's expensive. If this query runs very often, you're making SQL Server take on the expense of re-optimizing this thing every single time, which isn't cheap. It will not touch the plans in cache, though. If you put recompile in a query, it'll ignore the cache altogether. The cache is over here. You're over here. This is a useful solution, though, for queries that execute infrequently. If you have some giant reporting query, big, complex, and messy, that has very, very different values for the parameters, maybe it runs once an hour, and the parameter values change wildly, and parameter sniffing is a huge issue, you know what? It's running once an hour. Recompile is fine. No biggie. If it runs once a second, that may not be a good idea. It may be an okay solution, but you're going to pay a price for it, and that's going to take longer to execute because you're going to compile it every single time, and that's not cheap. This can be a useful solution for queries that are very parameter sensitive, where the inputs and outputs change very often. I return 1 row, 1,000,000 rows, 1 row, 20 rows, 1,000 rows. Again, the more often you run it, the more pain you're going to feel because you're going to be recompiling, and SQL Server is going to be doing its job over and over and over again. So use caution when applying it. Do not spam this all over the place. Recompile is not a catch-all solution for parameter sniffing, but it's a solution. And it's not invalid, but just use it sparingly. How does this look? I take my query. I'm going to flush my cache in this database. Don't do that in production. Here's my query with one value, 1015. I can look in the cache and see, hey, there's my execution plan. Awesome. Now, I put option recompile on. Same exact query as before with recompile. If I look at my execution plan, it's great. If I go here and check my cache, I notice that my execution plan here wasn't touched. So my cache was left untouched. Execution count 1. It does not matter how many times I run this, F5 over and over and over and over until my finger gets tired. Doesn't matter. My cache remains untouched, and that query will create a brand new plan every time and not reuse it. That is what recompile does. It is potentially useful, but please use it sparingly. Use it when you know what you're doing, when the query is not going to run too often, and when you know that sniffing is a very difficult problem to avoid. Any questions so far on the beginning of our how do we solve parameter sniffing and make our lives better? And no questions is okay. I don't mind. I just want to stop every so often, take a breath, because breathing is good.
Yeah, no, I think it's good. Yeah.
Breathing is great. Air is
It's
good.
very, very good. I think the presentation is good and the breathing.
There we go. I took a breath. Thank you very much. I took a breath. That was great. Got a little bit of oxygen now, so we can keep going. Great. What are other things? So recompile, it's useful. Just be careful. Don't use it too often. Use it when it's appropriate, and don't overuse it. If you find yourself spamming it everywhere, you've got a bigger problem. If you really take any solution to parameter sniffing and begin applying it wildly, everywhere, blindly, you got a problem. You got an addiction here. And I've seen this happen elsewhere. I'm not joking. I have a story in a moment. It'll be great. You'll laugh, I hope, and not to cry too much. But we'll go on. Here's a solution to parameter sniffing that is ridiculous. I have seen this in production multiple times in multiple places, and it still boggles my mind. So what you do is you say, hey, I got a proc. It's running like garbage. I don't know why. It's parameter sniffing. I can't fix it. Let me wrap the entire contents in dynamic SQL and then splice in my parameters. What you're really doing is taking your parameterized query and breaking into a literal query string. So it's kind of executing the same way it would have had you just use literal values with no proc at all. It avoids plan reuse when you have different parameter values. It's kind of like RECOMPILE, except that if the same exact value is used, it will reuse the plan. But it's very confusing. Dynamic SQL is a wonderful tool. I wrote a whole book about it. This is not a very good use for it because it's wildly confusing. Like, why am I using dynamic SQL here? Oh, you're trying to avoid plan reuse. What? Why would you do that? And it's going to be very hard to read your code, very messy. You're going to have lots of quotes everywhere. SQL injection becomes an issue. Scope becomes an issue. Security becomes an issue. So in general, this is a very bad solution for parameter sniffing. It's really only a good solution in scenarios where we're already using dynamic SQL anyway. Therefore, it's okay to keep using it for this as well. But introducing it for the sole purpose of optimization is wrong, wrong, wrong. Don't do it. Please don't do it. Why? Well, here's what it looks like. I decide my thing's broken. I can't fix it. Let me wrap it in dynamic SQL. Ha! I'm crazy. Sorry if you've done this before, but I'm not calling you crazy. I'm just saying this idea is crazy. We all have crazy ideas. Anyway, here's my stored proc from earlier. I have wrapped my SQL command in here. Here's my query from earlier. I've spliced in my start date, cast it as varchar. Spliced in my end date, cast it as varchar. And I create a SQL command, and I execute it with sp-execute SQL. Wow, what a weird way to write a query. But you can do this. This is legitimate. It's allowed by SQL Server for reasons that it allows it, I guess. And now I go ahead and I run my brand new proc with dynamic SQL. I run it. I get a good plan. I run it for a wide range. I get a good plan. I run it for the non-existent range. I get a good plan. Cool. But when I look at my plan cache, I discover that I have 3 plans. Now, if I rerun it, that's okay. I rerun it a few times, and I do reuse the plan. So I'm not cheating. I got my reuses there. So there is some plan reuse, but I'm really just hacking it. Don't use dynamic SQL, please. It's weird. It's funky. It's a trap. You're going to do it, and your developers are going to be confused in the future and not like you for what you did. So just don't do it. It may solve your problem temporarily. You're creating future problems in not only how it executes, but also just in readability. It's going to be hard to read. It's going to be confusing. So just don't do it, please. You'll thank yourself later. All right. That's a bad idea. Well, how about this? I can tell a query to optimize for a certain value. I can say, hey, I know how this query executes. Exactly. I'm smart. I figured it out. I know my business logic. I know how this query executes. I'm going to tell it to optimize for a specific value that is representative of how this query executes. And when I do that, it'll always use that value and give me the great plan. This fixes your execution plan pretty much to use a single value. So SQL Server will optimize your query based on the value you provide it. The caveat is you really have to know what you're doing. You've got to know your app, know your data, know your queries, know your T-SQL, and be sure that what you're optimizing for represents both current and future use. Like all query hints, use caution when applying it. If your code changes in the future, if your app changes in the future, if your query patterns change in the future, this may stop being true, and you won't know it. Your developers may create a brand new API set of queries that runs against your database that uses this code path, and suddenly you're optimizing for a value that's irrelevant. And if that happens, you'll have bad performance. So you're doing something here that may be smart, but it may bite you in the butt later. You don't really know. In general, this is the sort of thing you do when everything else fails. Don't use it unless you have to, and it's better as a temporary solution than a permanent solution. If you're spamming it everywhere, you know you've messed up. If you're putting this all over the place as a solution to parameter sniffing, you're going down a bad path. Just like dynamic SQL and recompile everywhere and everything else we've discussed so far, redeclaring variables locally. If you're doing it everywhere all the time, you've made a mistake somewhere. You're going down a bad path. You're smoking something you shouldn't be smoking. Please stop. How does this look? I'll create a brand new proc again, optimize for, and all I'm doing to alter it is at the end of my query, I'm going to optimize for a specific start and end date. In this case, I'm saying optimize for a very narrow set of dates. I know that narrow date's what I want, therefore optimize for that. Go. So I will now create my proc, and I'm going to run it now for a narrow range. I get a great plan. I run it for a big range. I get the wrong plan. A index seek sounds good, but if I'm really scanning the whole table, I do want an index scan. So this seek is actually not what I wanted here. I got the wrong plan. Now, if this is a very infrequent execution, probably okay. But if this becomes the more relevant use case, maybe I begin running some analytics against this table and big ranges are more common, well, now I'm in trouble. The rest of my values are optimal. A non-existent value, optimal. Another narrow range, optimal. But again, this one scenario here with the big range of dates that returns 45,000 rows, that wasn't optimal. So the verdict here is that optimized for is probably a trap. If you truly know what you're doing, you truly know your business object, you know it's an isolated case, and maybe it's temporary, this is okay. But be cautious because like all traps, it's very easy to fall into it and use it in a lot of places. Because again, I fixed it, it went fast. I'll do it here and here and here and here and here. And now you're off in a dangerous place. So be careful using it. Optimized for is okay, but it's also dangerous. Here's kind of a cool solution. In newer versions of SQL Server, you can make a temporary stored procedure. If you know that your business logic is temporary in nature and it may change, you don't have to create a permanent object that is optimized and you get a plan and you use it forever. You can create a temporary stored proc. This is wonderful if you have business logic that's unstable, that's temporary, maybe you have a release going on that's going to have special stuff going on as part of it. This is great for temporary things. If you have a scenario where you have business logic to be temporary in nature, where you have an execution plan that really has a limited lifespan, like I don't want this running forever, this is perfect. Your performance is going to mirror what would happen if you create a brand new proc and begin using it right now. And this can be great because you can target it towards very specific code, use it, drop it, and it's gone. This is a great scenario when your query patterns are evolving and they're consistent and you know that this is temporary. It's kind of a cool use case and it works sometimes. But again, if you're spamming it everywhere, you got a problem. What does this look like? Well, hey, did you know you can put a pound sign in front of a stored proc? Well, yeah, you can do that. It's pretty cool. So I'm going to go ahead and create my temporary proc here like this. Same exact code as earlier. It's parameterized. It's temporary. Cool. There it is. This will continue to persist in SQL Server until either my session ends or I drop it. Now I'm going to execute my temporary proc for a narrow range. I get a good plan. If I run another narrow range, with nothing in it, I get a good plan. What if I were to put in a broad range? I do get the wrong plan because I got plan reuse and that wasn't what I wanted, right? Actually, I'm going to save that for later. This is useful. We'll keep that there. It's cool. Anyway, so it really behaves like you have a proc that exists, but when I drop my session or I drop my proc, it's gone. So now that I've dropped the proc, the execution plan's gone forever. Kind of cool. So this is useful in moderation in temporary scenarios. If you find you're using it all over the place, you've entered the trap again. Really, any solution to this should not be a catch-all. But a temporary execution plan and a temporary stored proc and all the things it entails is wonderful when you have a temporary problem to solve that will go away later. Maybe you have some code you're running over and over for a release, and it's going to vanish forever. This is a wonderful way to deal with it. But temporary is the key word here. Any questions up to this point about any of the solutions I've talked about so far with parameter sniffing?
Well, I'm good. So far, so good.
Okay, no problem.
Pollack, I have one question that
Sure.
is on dynamic one because in my project I use most of the processes are in dynamic only. So could you please repeat that statement how we can improve in the dynamic level?
If you're already using Dynamic SQL, you're doing what you can. You can parameterize Dynamic SQL, though. One thing I did not do in my example here is parameterize it. You can parameterize Dynamic SQL. Feel free to look this up on the internet. There's lots of demos out there. I've demoed it personally. on articles and in books and things. You can find lots of examples though. SPXecute SQL could be parameterized. You can pass in a query and pass in
Okay.
parameters and then reuse your plan. And that is a wonderful way to allow dynamic SQL to be parameterized and have plan reuse. This specific use of it here, where you splice in values, will cause plans to get regenerated over and over a lot and may not be ideal.
Okay. And I have one more doubt. So is there any much difference between execute SP underscore SQL and only execute that SQL command?
The major difference is that SPXecute SQL allows you to parameterize your SQL and pass in parameters, and those parameters kind of protect you a bit from SQL injection. I generally
Okay.
recommend using SPXecute SQL whenever you can. There are differences though. This has got to be an nvar. There's some details that matter, but I would look into using this instead if you can, the syntax. It isn't critical, but it might make your life easier, especially if you want to parameterize. Parameterizing it is super valuable. It will make your dynamic SQL a lot more versatile, and it'll kind of help your ability to reuse plans and not blow your cache up a lot by doing a lot of different plans. So I recommend it in general for both security and for plan reuse and kind of readability, because all this gobbledygook here with lots of apostrophes goes away. You'll just have your parameters in there.
Okay. Yep. Thank you.
Sure, no problem. Thanks for the question. Let's continue. This is a trace flag. The moment you're in trace flag land, you got to know what you're doing or you're doing bad things. This trace flag is an example. There's many, many trace flags and query hints and ways to muck with the optimizer to get what you want. This trace flag essentially disables parameter sniffing. It's basically kind of like optimizing for unknown, which is kind of like when I use local variables. SQL Server takes a wild stab in the dark, makes a plan, and uses it. This is server-wide. If you have a specific query hint, it may override it, but this is a big deal. This is generally a bad idea. You'll probably never want to do this, and if you ever feel like you should be doing this, don't do it to your whole server. Do it to one database or one query. Really isolate it. If you're going to do crazy stuff, isolate it to the place where the crazy is needed. Don't make your whole server crazy. So really, this is a bad solution. If you're using it, you're probably going down a bad path. If you can isolate what you're doing more, you'll benefit in the future from it. And really, I'm not even going to demo it. Just kind of avoid trace flags unless you truly 100% know what you're doing and are certain it's the right solution. Otherwise, don't do it, please, please. So that's bad. All right, here's where I say what nobody wants to hear, but we all know it's true. And as an architect, which means I'm both developer and DBA and all these various roles in one, I do Q, I do everything. I know what this is like. The most common reason why you have parameter sniffing is because you have code problems. I'm just being honest here. You have code issues. Your code is big, it's complicated. And what does this mean? I say, improve your T-SQL. And you say, oh, no, I don't want to. It's a lot of work. It's time, it's work. But you know what? This is the permanent solution. Many of the things I talked about earlier can be used as temporary solutions to parameter sniffing. This is really the permanent solution to a lot of scenarios that you run into. So how does complex code beat us up and cause trouble? This slide is all about that. A majority of parameter sniffing is caused by complicated code. If you have stored procedures that are 5,000 lines long, that's a great source of parameter sniffing because you have complicated code. What is going on in those 5,000 lines of T-SQL? How many different code paths are there? If you have if, then, else, while, go to all over the place. If you're branching, ever seen a stored procedure that has a flag passed in, a run flag that says, if it's 0, do this. If it's 1, do this. If it's 2, do this code over here. That's branching. And in general, you will have parameter sniffing in ways I can't begin to describe if you do that, because you may optimize your query for use case 1, but then you may reuse your plans for 2, 3, 4, and 5, which were irrelevant before. So in general, the more code paths you have, the more opportunities you have for parameter sniffing. And if you run into parameter sniffing in a stored procedure that has lots of code paths, consider breaking it up into smaller procs. Take your proc with 10 switches and break it into 10 smaller procs. And yes, this does sound painful. It sounds like work, and work can be annoying, but ultimately it will make your life better because now you have one proc that does one thing, another proc that does another thing, and another proc that does another thing, and they're all different things. That will make you get rid of your parameter sniffing forever. Huge. In general, just avoid the multi-purpose procs, evolve the switches, the use case flags, the giant crazy list of parameters. That's another great scenario. How do you get parameter sniffing? Well, if you have 30 parameters in your proc, well, that's a great opportunity for parameter sniffing because you have 30 parameters. So much can go wrong as they change, right? You have more opportunity for sniffing to occur when you have so many values, especially optional parameters. If you have 1 parameter that's required and 29 that are optional, you are begging for sniffing because you get all different combinations. Similar, if your proc is ginormous, you have lots of opportunities there for sniffing. And you have too much business logic in your code that's causing you trouble in your SQL. Again, the easiest way to solve is break it into smaller pieces. Or if you have way too much business logic in T-SQL, push it into the app. I know it's hard and not everyone likes doing it. And sometimes devs will push back. Architects may push back. Architects like me may even push back sometimes because it's a lot of work. But ultimately, if you can prove out like, hey, this proc's 10,000 lines long, 5,000 of it is formatting XML. I don't want to do this anymore. That's a great reason to shrink your proc. Do your 5,000 lines of XML manipulation in code. Don't do it in the database. Is not an XML engine. It has it. You shouldn't do that. So shrink it, simplify, push things that can go to the web layer or your app layer or elsewhere when you can, and make your life better. Parameter sniffing can happen when you hack too much. Maybe you tried to optimize your queries and your procs, and you started hacking a lot. You put an optimize for here, a recompile here, a no lock here, and suddenly your proc is sprinkled with all kinds of hints. And all those hacks added up made your proc get a weird execution plan that isn't really the right one. Maybe it worked a year ago, but now it doesn't. Again, too many hacks result in bad things happening. Try to remove the hacks and figure out what's the real cause for bad plans and solve it. And one last note is that you may be using the wrong tool for the job. If you have an OLTP database with, lots of transactional stuff going on, updates, deletes, and inserts, and you're also trying to run your big data reporting against the same database with your giant reports against billions of rows of data, you're destined to fail. If you run OLAP against OLTP, OLTP against OLAP, if you try to use tables as queues instead of service bloker, if you have mountains of XML and string manipulation and full text scariness going on, and it's just really slow and you're not sure why, you may just be using the wrong tool for the job. That's okay. Explore other tools. Take time to take a deep breath and experiment and see what else is out there. Could I use Service Broker as a queue instead of this giant proc that analyzes a table and pops rows in and out? Maybe that'll be better. Maybe a different service altogether would be better outside of SQL Server. I don't know. But consider other alternatives to what you're doing. The moral of this page, this whole slide, this whole idea is that the most likely reason you have parameter sniffing and it's causing you trouble and making you frustrated is because your code is inviting it. It won't always. All the demos I showed today intentionally run a very simple query. So that does prove that you can have sniffing on a simple query. But more often than not, when I've personally found production issues that caused headaches, it was a 10,000 line proc. It was a proc with 30 parameters. It was a proc that had dynamic SQL from beginning to end. Things like that just made the optimizer do bad stuff, and it was my fault. And I took responsibility for it, and I fixed it, and in the end, we were better off. So really, this is the best thing you can do, but it's also challenging. Rewriting your code is hard, but we have many other solutions available we've talked about already that can be potentially useful as temporary solutions. If your production environment's on fire and you don't know why, and an optimized for fixes it, by all means, fix your flaming production environment, make it work, and then go back and fix it permanently later. Definitely 100%, no question about it. Your users, your applications, your most important people that rely on this stuff every day, do that first. Do the rest later. Your due diligence can come a little later when you have time. You can take a deep breath. There's so many more database hacks out there. This slide is really just a summary of it. I'm not going to dive too much into these. You can turn off parameter sniffing on databases. You can optimize for unknown. You can optimize for ad hoc workloads. That could be useful if you have a server that manages lots and lots of queries that are always ad hoc in nature. It'll help you not cache the first time and then cache it later. You can set force parameterization, which will take ad hoc queries and try to parameterize them. Again, in a very ad hoc environment, it could be valuable. These are hacks. They will work under very specific circumstances where you truly 100% know what you're doing. In general, I highly recommend that if you're going to hack at the smallest granularity possible. The query level, not the server level. The table level, not the server level. The database level, not the server level. If you can, help it. Keep it as low level and granular as possible. Don't blow your whole server up if you can help it, unless you know for sure it's what you want to do. These are hacks. They're things that may help you occasionally, but again, I call them hacks because you're breaking how SQL Server works to try to make things work a different way. And you might be right, but more often than not, you may not be. But again, if enough research says you're right, by all means do it. Just beware again of spamming hacks all over the place. If you're setting parameterization forced everywhere, if you're turning off sniffing everywhere, you're probably falling into a dangerous hole that you don't want to fall into. So I want to have some time for questions at the end. I'm going to take a deep breath and wrap up now. The key to everything I've talked about so far is that plan reuse is an important part of SQL Server. It's important to how it works. You need it. If you don't have it, you're in a very weird world where you're recompiling every proc that executes and things are going to be slow potentially. Because optimization is expensive. It takes CPU, it takes time. It's not cheap. The optimizer is a complicated piece of software. It's proprietary. It isn't every product. So you don't want to overuse it. In general, parameter sniffing is not a mode, it's the outlier. If you see it, it should be taken as this isn't the way it's supposed to work. It's always right except for this. That's what parameter sniffing is. So don't see it as the mode, see it as the unusual edge case and not what always is. If you find a solution to parameter sniffing, don't spam it everywhere, please. If you do that, you're going to suddenly have dynamic SQL everywhere or optimized for unknown everywhere. And once you do that, you're in trouble because you're applying the same solution everywhere thinking it's going to fix things. And I promise you, it won't. And just avoid hacks that make the problem go away. And if you do hack it to make the problem go away, make sure you revisit it and fix it permanently later. Don't leave the hacks in place because they are ticking time bombs. They will cause you trouble in the future. The optimize for unknown will eventually give you a bad plan that will break your server, especially if your table is small today and giant tomorrow. Like, hey, I worked on a table with 1,000 rows. Hey, it has 1 billion rows and it isn't working. Why not? Oh, I scanned 1 billion rows? Whoops. Shouldn't have done that. That was a bad idea. Worked in dev. Don't do that. Ultimately, your best solution for fixing parameter sniffing is improving your code. Look at what is causing your troubles and think about, is this really sniffing as a problem? Or did we just have a crazy proc, some crazy code, some crazy ORM generated SQL that it's too big and too long in one chunk? Think of ways to simplify it. Think of other ways to write better business logic, better code, better SQL. And this is not a simple thing to do. This can require a lot of experimenting, a lot of experience, a lot of research. Don't be afraid to do that, though. This is a great thing to do. It makes us better at what we do when we learn better how things work. And there's lots of resources out there to help you. There's lots of articles written on this topic. I've written stuff about it. You can talk to people like me, others out there. There's lots of resources in the community to talk about parameter sniffing and how to solve it. And there are lots of people who have been through the exact same thing before, and they'll be happy to share their experiences. With that, we're kind of nearing the hour that I was allotted, and I do like to respect time limits and our free time. So I'm going to kind of open it up now. Here's my contact info. Feel free to tweet at me or email me whenever you'd like. I'm happy to respond to questions and thoughts and recommendations and ideas. If you think there's something I missed here you want to talk about, we can talk about it. I love talking. But are there any questions right now about anything in this presentation or anything that was not in this presentation?
I've got a question. Is there any way to tell, like, so if it's, parameter sniffing in like a stored proc or something like that, as opposed to like through entity framework, is there an easy way in the plan cache to kind of tell that this came from a stored proc as opposed to from entity framework code?
Yes. So the key is going to be when you go to your plan cache and take a look, what you will see is create procedure. You may get other execution plans that are spawned below that if it's a very large and complicated proc and there's functions and views and other things inside of it, but you will get at least a header in there. You'll get an execution plan for the proc, and then you'll know that a proc was where this came from. And you can then look at the plan and dig in further and understand better what caused it. So that will appear in the execution plan cache, and it will provide you a hint as to where it came from. And if you ran a trace or extended events, you would see that in there as well. If you did a full extended events profile of, statement completed, proc completed, everything, you'll see all of it. You'll know there was a proc, there was these 5 statements inside of it. You'll see everything, and you can then kind of narrow down which piece of it was kind of cruddy and why.
Okay, thank you.
Sure.